Okay, we got a rental company. They got, wow, 2,400 apartments available. 800 are currently rented at $500 per month. So right now they've got 800 rented out. They're charging $500 a month. So 800 times 500 means their revenue currently. But they say if they decrease the price by $5, they'll get 20 new leases. So decreasing the price increases the amount of money they make. So we're supposed to determine a revenue function, R of X, that models the total rental income, where X represents the number of times we increase the monthly rent. So when X equals 1, the price is now $4.95. Okay. When X equals 2, the price is now $490, right? X represents how many times we change the price. So the basic idea we're dealing with here is that the revenue is the cost per apartment, the price of each apartment, I guess I should say, times the number of apartments, right? You got, right now we have 800, sorry, it's $500 here, and it's $800 here. But those are going to become variables because of what they told us. The price of each apartment, it starts at 500, and I'm going to keep it blank there. And the number of each apartments, we start with 800 apartments rented out. But it's going to fluctuate because we're going to try to mess around with the price. We said that if we decrease the price what did it say? If we decrease the price by $5, then we should be able to increase 20 new residents, right? So minus 5 over here causes plus 20 over here, right? And if you do another increase, if you go minus 10 over here, then you should have plus 40 residents, right? So we need a variable to represent all the different prices we could use. And the variable you want is X, where X represents the number of times you change the price, okay? So if X equals 1, you've dropped the price $5. If X equals 1, you've gained 20 new residents. If X equals 2, you've dropped the price $10. If X equals 2, then you've gained 40 residents. So the full complete function, we have it up there. I'm just writing it more succinctly. Okay, and you might not see it immediately, but this is quadratic, right? Multiply these two parentheses together and you're going to get an x squared out of it. That means it's a quadratic expression. So I'll do that. I'll multiply 500 times 800. That's 400,000. 500 times 20. I really should know what this is. That's 10 with 3 zeros extra. I doubt myself a lot when I make videos because I don't want to remake the video. Negative 5x. So here, I've done this. That made 400,000. I did this. That made 10,000x. Multiplying this, that makes negative 4,000x. And I'm going to do this. That makes negative 100x squared. So if you combine like terms, this is 400,000 plus, we've got 10,000x minus 4,000x, that makes 6,000x, and minus 100x squared. There we go. We have a function that represents the revenue. This is also a function that represents the revenue. Either one is fine, okay? This one down here is closer to standard form. What did we determine? Okay, we did that. We're supposed to graph this function. Okay, so actually I'm going to do part C before I do it. You could use desmos.com/calculator to graph this, but we really want to use what we're learning in this section to help us graph this. Okay, what's the maximum income? Look, if this is quadratic, A is negative. That means the graph of revenue will look something like this. It's going to hit its peak at some point. And we have a word for that peak, a mathematical word, right? That's the vertex. So if you want to maximize their revenue, you want to know where we hit the vertex, which is this formula right here for the x coordinate of the vertex. X equals negative b divided by 2a. Where my b in this equation up here was 600, so that's negative 600 up here. And then my a is negative 100, so this is 2 times negative 100. So if you simplify, it's negative 600 divided by negative 200, so what is that, 3? So that means we want to we want to decrease the price by $5 3 times. In other words, we want to decrease it $15. Okay, that's the location of the vertex. The question here, well, we want to know what the vertex is so we can graph it too. So that's our x coordinate of the vertex. To find the y coordinate, you'd plug 3 back in. And so if you can plug it in either in this one or this one, it should be the same thing. So I'll use the bottom one. I'll do the squaring first. 3 squared times that 100, and that's a negative 100 because the negative sign. And then 612, that's 1,800 plus 400,000. I guess they were already close to the max price, so it looks like 400,900. I just made up these numbers too, so that might be why. So they're already doing the right thing here. They're just off by a little bit. If they increase the price by, if they decrease the price by $15, then they've got the max revenue. Okay, so to find out, to answer their question, what rent will yield the max revenue? Well, actually, sorry. Let's go in order. Let's graph part B. All I wanted to see for graph B is that students know that you only graph it where x is positive. Actually, no, it could be negative. Sorry, it could be negative. But I really just wanted to see the vertex. You could just change the interval of the y-axis to say that this is 400,000 up here. There's a dot up here. So this is a graph of what it would look like. We don't care about the graph when it goes below because we're definitely not going to set a price that's going to make negative revenue, right? Okay, so that's a rough sketch of the graph. That's all we're looking for part B. For part C, what rent will yield welcome home? We just found out that x is 3, but remember, x isn't your price. X is how much you should change your price, how many times you should change it in increments of negative $5. Up here, the price of our apartment, we had this mini expression for it, right? So you want to plug 3 into that expression because 3 gives us the maximum. So if I plug 3 in there, I've got 485. So 485 is the price that would give us our max revenue. Now, if the question was different, if it said how many, if the question said what was the maximum revenue, then you'd plug x equals 3 into this function here because that would tell you your max revenue. Okay, you plug 3 into this equation, that would tell you what your maximum revenue is going to be. But the question said what price should you set these apartments, so that we only want to plug it into this part where we calculate the price of the apartments.